Hello everyone, in this video I'll be explaining you the problem fence coloring. So actually I already had shooted this video, but at the end my laptop got switched off, so again I have to shoot it now. So yeah, let's read out the problem. You have n fences and you want to color them. You have n total types of colors numbered 1 2 up till n. Currently all the n fences are colored with type 1 color. At the end you want the ith fence to have a color of a of I for every I greater than equals to 1 less than equals to n. So you can choose to do to one of the following at each minute. Color all the n fences at the same time with type x color, where you can choose x greater than equals to 1 less than equals to n. Color a specific fence I with type x color, where you can choose again x greater than equals to 1 less than equals to n. So now yeah, this is basically all the fences you have to color with x, and this is like only specific fence which is present at index I. So both of the above operations take only 1 minute to perform. What is the minimum? We'll have to find the minimum number of minutes needed to color the entire fence as desired. So yeah, don't worry, I'll be explaining you on the board. So we have integer t denoting number of test cases. For every test case we'll call a function solve. So for every test case we have n fences, and so I'll be not taking in a vector all the desired fences. I'll be telling you why I'm not taking. Don't worry. So there are three test cases. In first test case we have two fences, and we want color as 1 comma 2 at the end. So what is the question? What they're saying? So right now, initially, let me denote it as I. We have two fences colored as 1 comma 1, and the final color of the fences has to be 1 comma 2. And what they're saying is, in one operation what you can do is you can choose any color x, uh, and x should be between greater than equals to, I mean less than equals to n, greater than equals to 1. Yeah, it is looking. So you will have to color all I. For all I you have to color with this x. Okay. So second operation what they're saying is you will have to choose specific index I, and you have to color that index with I mean that fence with x, and again x is greater than equals to 1 less than equals to n. So these are two different operations that we'll have to do. So now we have initially 1 comma 1 as color, so finally we want 1 comma 2. So let's try to apply the first operation. If you try to apply first operation, and if you try to put, let's say, 1 comma 1 color we have, and your coloring has to be between 1 to n, which is 1 comma 2, only two colors you can choose. So let's say initially it has 1 comma 1 only. Now you want to color, let's say, both this with 2, so you'll apply first operation. So your color will be of this type, and while doing this you require 1 minute of time. And now since you required 1 comma 2 but you have 2 comma 2, so now you will be coloring this index using second operation. You're choosing specific, this is one based indexing, so index is like 1 comma 2. So first index is choosing and coloring with x is equal to 1, so your color will be this, and this will be done in one more minute. So total of 2 minutes you are taking. So now is the question, is this the optimal way? No, this is not, because so you have 1 comma 1. What if directly you choose this fence and color with 2? So that will be 1 comma 2, and you just require one operation of time, sorry, 1 minute of time. So which is using second operation. So obviously 2 minutes, 1 minute is less than 2 minutes, so this operation will be doing. So how do you solve this problem? From this example you can't derive how to solve it, but let me take you other examples and tell you. So we have second example is 333. So first problem was just to understand it. So we have n is equal to 3, which means 3 fence we have. Initially all colors are 1, you want color as 3. So how do you do it? This is initial and this is final. So if you try to apply second operation one by one, so your intermediate, let's say you want to apply for this one, color 3, you can color with 1 comma 2 comma 3 because from 1 to n these three types of color there, you can choose any. But if you try to choose the color 2, that is basically waste of time. If you because in destination we don't have any color with 2, so don't choose 2. We'll be choosing only 1 comma 3. So now I want to apply second operation one by one. So this will take me 1 minute of time. Since this is colored and this one I want to color it, so I'll be coloring using one operation, because in one operation you will have to choose specific index. So one index I'll be choosing. This is requiring 1 minute of time. Now I'll be choosing third index. I'll be coloring it by 3. So total of 3 minutes required. But this is not optimal. What if you try to take operation 1 and do it? So how do you do this? I'll be taking operation 1 and color with 3 all the fences. So this would require only 1, and this is our final what we need. So this is only 1 minute. Obviously 1 minute is lesser than 3, so we'll be choosing this operation. So yeah, 1 minute is the answer. Let's try to understand sixth one. So sorry, it was third one, not sixth one. We have 213, 252. 213, 252. So initially all colors are 1. This is initial and this is final, what you require. So in order to solve this, what you have to do is, since you can color all the fences with one color, so and you want to minimize the amount of time, so one approach in my mind that comes to is that whichever element has more frequency, that color basically that color I'll choose. Let's say here frequency of 1 is 1, frequency of 2 is 3 because we have 3 times 1 2 3, frequency of 3 is 1, frequency of 5 is also 1. So whichever color's frequency is more, right, so that color I'll choose basically and try to color with all the colors. Why? Because using one operation, first operation, you can color all the elements in 1 minute. So which color you want to color, which color type you want to color all the fences, so that is basically whichever has maximum frequency. So in this case 2 has maximum frequency, so what I'll do is I'll color with all 2. So we have colored this in 1 minute, but your requirement is now this 2 1 3, so all are having 2. So now if you want to color 1, so this should be as it is, and you will be coloring this I type using second operation, because now if you use one operation, first operation, so in that case again all the colors will be changing. So coloring one type of color for all and doing the other color for all is like waste of time. So you should color all the elements of the fence only one time, and that should be in the maximum frequency, because one fence coloring with specific type requires 1 minute of time. So if you try to color the fence which has maximum frequency, that you can do in 1 minute only, and that is the reason I'll be choosing maximum frequency. So now this will be done in 1 more minute. Now we have 3 here, so I'll be coloring this with 3. This can be done in 1 minute. Now we have 2, which is correct. Now we want 5. This can be done in 1 minute, and we have at the end 2. So this is our final array what we require, final fence color. So how many minutes we have spent? We have spent only 4. So this is the approach that I'll be solving. And how did I arrive this approach? In context, how did I came to know about this approach? So I thought of one trivial case. Let's say we have 1 1 1, 2 2 2 2 2. Okay. So in this case, initially you have all ones, but you want to achieve this. So I have counted frequency of this. So frequency of this is 5. So I'll be basically coloring all this with 2. Okay. So this is whatever required which is correct. This one will have to color back to 1. So this I'll do it 1 minute, this I'll do it 1 minute, and this one in 1 minute. So 3 minutes, and this one I'll be doing it in all the colors I've done it in 1 minute. So total of 4 minutes is required. Okay. So how you will do this? So, and which is our optimal answer? Like if you try to uh, color these five elements we have one by one using second operation, you require 5 minutes, because initially all are one, so this one is match, this one is not matching. So if you want to try color with 1 2 2 2, so you require 5 minutes. But if you see 4 is better, right? So that's why whichever frequent color type has more frequency in the final, choose that and color all the elements with that. And so your since you want to color all the elements, right? So basically you will be doing in n minutes ideally. Okay, like let's say you have 1 1 1, but you require 2 3 4 as the color. um, since x is lying in the range 1 to n, 4 will not be there, but you require, let's say, uh, 2 3 1. So this will be done in max of 2 minutes, right? But what if it has, let's say, 2? So this can be done in only yeah, this can also be done in 2 minutes only. So what, like actually what I'm trying to say is that whichever color has more of frequency, that I'll be coloring one go. And my answer, since this all colors I'm doing in one go, so will be reduced by the frequency of max element. Because this one you have done it in 1 minute, and rest all element whatever you have, that you are basically coloring in how many minutes? The number of elements, basically n minus frequency of this. N is total and frequency of this is 5. So here n is 8, frequency of this is 5. So you require 3 minutes, right? But ideally you require 4 minutes. So for this answer you will have to add +1. Okay, so this is one case, like wherein max element is not equals to 1. If suppose, let's say, we have element 1 1 1 1 2 2. So in this case, since frequency of max element is 4 and it is 1 only, so and like initially all the elements are 1 only, so you will have to only do color with these two elements. So if you do this coloring of 2, you require 2 minutes of time. So in this case our frequency will be n is 6 and frequency of max element 1, which is 4, which is equal to 2. So here, like, why I'm adding +1 there, why not in this case, like max element in max frequency element is 1. Whenever 1 is there, so that is you know you will not be coloring. That's why you are not adding 1 here. It will be simply n minus frequency of 1. Okay, but in case of um element having different color other than 1, since initially 1 is the color that you have, so, and there is different elements, so you will be requiring 1 minute to color all the elements, right? So that is the additional +1 that you'll be adding. So I think now it is very clear. So let me try to code it up. So I'll be not taking vector, I'll be taking just unordered map. I'll take int temp, which will basically, I'll take the final fetch color that you need. So in temp I'll be taking the final fetch what you required. So in this map I'll be increasing its frequency, and now what I'll be doing is I'll find the max frequency. So initially let me take max frequency as 0, and the max element whatever we have, that is also, let's take 0 or -1. Let's take, since -1 is not there in this case, like our element will be from 1. For to start with, I'm taking -1. Now what I'll do is I'll go over all this map, and if I see this frequency of the current element is greater than the max frequency, so I'll point this max frequency to current one, and our max element will be this current, element. When I am coming out of the loop, let me initialize answer as 0 first, and I'll be checking if this max element is equals to 1. So I just showed your answer will simply be n minus max frequency, n minus max frequency. Okay, but in case your answer is not 1, so in that case, I mean the max frequency element is not 1, so in that case you will be basically making all 1 to that max element, so 1 minute you're doing extra. So your answer in that case will be n minus max frequency whatever is there plus 1 minutes you will be requiring, and at the end you'll be just outputting the answer. Let's try to run it. Okay, my bad, I'll have to take this dot. It is not pointer, since it is auto will give reference, so dot will give its value. So yeah, we are getting 214, which is not correct. I think somewhere we are missing. Just give me a minute. Max frequency is initially 0, let's say. Let's try to debug for this one only. So in unordered map we have 1 as 1 and 2 as 1. So IT dot second is basically, you know, okay, so IT dot second is okay. So what I'll be doing is I'll be again here checking. Whenever we have max frequency element with equal to 1, which means in this case if you see both 1 and 2 has max frequency as 1 only, so in this case choosing coloring only 2 is the right one, right? Because if you want to color with 2, this is taking extra time. So what I'm trying to say is that, so we have 1 comma 2, but according to our logic what we are doing is whatever frequency we are having, right? So its frequency is 1 and its frequency is also 1, but in the case we are checking greater than frequency, initially it is -1, but we are checking the current frequency is greater than -1, which is true, let's say. And since we are using unordered map, so it may happen that 2 will be getting at the first time, so in that case your max element will be 2 only. So in that case what you are trying to do, actually you are trying to convert to 2. This require 1 minute and you want to convert this to again back to 1, so again 1 minute, so 2 minutes are taking, that's why it is returning. So instead of using unordered map, I'll be using ordered map. So ordered map, whenever I use it, let's say some element, let's say 111 22 333 we have, right? So if I try to use ordered map, your maximum frequency elements are 1 and 3 both, but ideally taking one, this one is optimal. Why optimal? Because this you can color in 5 minutes, but if you want to color with the 3 first, so it will take 3 3 3 3 3 3 3 3, so this is taking 1 minute time, and this one you will be coloring back to 11122, so this will again take 5 minutes, so which is ideally taking 6 minutes of time. So using ordered map is good. So I'll not be using unordered map, I'll be using ordered map. Now let's start to run it. So we are getting 114. Let's try to submit it. I think you guys got to know like why I'm using ordered map, why not unordered map. So yeah, it got accepted. So I think you guys got to know how to solve it. If you have any doubt, you can comment me. I'll try to definitely help you out. So yeah, thank you guys for watching the video.